teeth hurt, weird things like teeth hurt sometimes. So,
Oh, I'm sorry.
That's all right. All right, so they want to find the derivative of g of theta. So g prime of theta is going to equal, the quotient rule says it's low times the derivative of the high, which is negative sine theta, low d high minus high d low all over low squared. But now we're going to clean this up a little bit. Got to simplify it. So this really is just theta to the 6th power. So notice that 2 of them will cancel with 2 of these and with those 2. So that's how that turns into the 4th power. And so cleaning this up, I would put the negative, this negative in front. Negative, can you see my screen okay?
Yeah.
Okay, negative theta sine theta minus 3 cosine theta all over theta to the 4th. So again, low d high minus high d low. The low times the derivative of the high. In other words, the denominator times the derivative of the numerator minus high d low, numerator times the derivative of the denominator all over low squared or denominator squared. Okay.
I mean, to be honest, what I don't get though is just why didn't you cancel them out completely? Like, why didn't you make the bottom 3 and the top 0?
Say that one more time.
Oh, why didn't you make the denominator?
You're talking about the thetas?
Yeah.
Okay, because I think of it like this. I could factor out 2 of the thetas out of the top, and you'd have negative theta sine theta minus 3 cosine theta. And then in the denominator, I would have 6 thetas. So how many would cancel out?
Oh, 2.
Yep, 2 would cancel out. So you'd have 4 left on the bottom, and those 2 would be gone from the top. That's what I did. So you have to make sure you're canceling them out from both. What do both of these have in common? They both have 2 thetas.
Okay.
This term has 2 thetas, this term has 2 thetas, and the denominator has 2 thetas.
Okay. So it was just a problem with canceling then. Okay.
Yeah.
Thank you.
Yep.
I have one other question. I can paste it right now.
Yeah, go ahead.
It's on the second slide.
All right. So this is going to be a chain rule. Actually, have you learned the chain rule yet?
Yeah, but yeah.
You can do it with the chain rule, or you can do it without the chain rule. If you want to rewrite this, it can rewrite into this. I guess you still have to use the chain rule in a sense. So it would be, the derivative of this would be low d high. So the derivative of the numerator, I'm going to have to use the chain rule for this. All right, it's going to be the derivative of the square root of 2x plus 3 is the outside of it. So I take the derivative of the outside, which is that, to the negative 1/2, because I subtract 1, times the derivative of the inside, and that's that 2. So I'm using the chain rule here. Okay, minus high d low which technically I don't really need the chain rule because the derivative of the inside is just 1. So really, I don't even need to do the chain rule. I just have to take the derivative of it, which is 1/2 x minus 2 to the negative 1/2 all over low squared, which is just going to make that go away. Okay, now this is tricky because I have to simplify this. So let's rewrite these things. Those 2's cancel. I'm going to use red to rewrite it. Those cancel out, the 2 and the 1/2. Right? So I'm going to have the square root of x minus 2 all over the square root of 2x plus 3, because that's what this is right here. Got it? Minus the square root of 2x plus 3 all over the square root of x minus 2, and this has a 1/2, so I could write just a 1/2 up there. I have to write the 1 on the top, but that 1/2, that 2 would stay in the bottom with that. See how I'm doing that? Again, algebra is the important part of calculus. It's the tricky part often of calculus is algebra.
Oh, okay.
And I'm still not done.
Yeah.
So now I'm going to do what I call clearing the fraction. Okay. So I'm going to multiply the top and the bottom by the least common denominator of these fractions right here. So I'm going to multiply this by the square root of 2x plus 3 and the square root of x minus 2 and 2 on the top and the bottom. Okay. Now, why would I choose to do that? Well, because when I distribute this in here, what's going to happen when I multiply that into there? What's going to cancel out?
When
I
multiply minus 2. Oh wait, like the like roots. Sorry.
Yeah, the square. This is going to cancel with this, right?
Yeah.
And this times this, you're right. The square root cancels out. So really, all I'm going to have left is 2 times x minus 2, because all the other stuff's going to cancel out. Okay. And when I multiply this thing here, same deal. This cancels out. The 2 and this cancels with this, and this times this, the square roots cancel out. So I just get negative 2x plus 3, and don't forget to keep your parentheses there. Okay.
Okay.
All over. In the denominator, all I've got is x minus 2 times 2 times the square root of 2x plus 3 times the square root of x minus 2. And now I just simplify this whole thing. So this equals 2x minus 4 minus 2x minus 3 all over that mess, which just equals, those go away, negative 7 over 2x minus 2 square root of 2x plus 3 square root of x minus 2. And that's your answer.
And one thing I would want to ask is, you said that you really didn't have to take the derivative of this.
Mm-hmm.
Or
yeah, I didn't have to take the derivative of I didn't have to use the chain rule is what I was saying. Oh, because what's the derivative of the inside?
The derivative of the inside?
Yeah, what's the derivative of x minus 2?
0.
It's 1.
Wait, 1.
It's 1. So do I have to really write that out here? Does it change anything for me to multiply it by 1?
Well, no, but I think my teacher kind of told me that, like, if you have an actual expression inside of like a square root, then you really can't do then you really kind of have to do the chain rule.
I did do the chain rule, but the difference is what's the derivative of what's inside here? What's the derivative of x minus 2?
1.
It's 1. So the chain rule says multiply the derivative of what's inside there. But does it really matter if I multiply it by 1?
Oh, so you technically did do it. You just
Yeah.
didn't write the 1. Okay.
Yeah. I mean,
Got
it. Because the chain rule, yeah. So in theory, I did do the chain rule, but since the derivative is 1 on the inside, you don't really have to write it. Do you have the answer key for this, by the way?
Yeah, I do. Here, I have it.
Is this just tell me if I did it right, because
He doesn't show his work, but
I'm wondering how he writes his answer.
he likes it like very simplified, to be honest.
Which is probably the way that I wrote it, I would think. I guess you can write the x minus 2 to the 3/2 power, I guess. I suppose you can write it a little bit simpler if you write it as, but I don't know if he wants it like this. -7 over 2 times x minus 2 to the 3/2 times 2x plus 3 to the 1/2. That's a little bit simpler because the x minus 2 is together.
Okay.
Yeah, that's pretty much what it, yeah. So 3/2 is this right here.
Yeah. Oh, I know. Thank you though.
Yep.
But one thing I kind of would want to know is, I'm not gonna lie, it was one of my friends. Told me like she was gonna do it this way. I can paste it on the third slide.
Okay.
She said that she actually did it like.
Yeah, you can do the whole thing in the chain rule if that's what you're saying.
Like
there's another way you could have done it.
Yeah, she did it like 1/2. She brought like the power down.
Yep. So she's doing the chain rule. Yes. So you could do it that way. Here, I'll finish it for you. So 2x plus 3 all over x minus 2
to the -1/2.
To the -1/2. And now take the derivative of the inside, which is low d high, which is times 2, minus high d low, which is just 1. So I don't have to write it all over low squared. But now you still have to clean this mess up. So it's still kind of nasty. But yeah, you could have done it that way.
Okay. I guess to be honest, it was more of like a hypothetical just to ask.
So let's do it. We'll do it and let's see which one's easier. Do you know what to do with this? The -1/2. What do you do with that?
I mean, kinda. I mean, it would kind of mean that entire thing would, except for 1, would literally go in the denominator.
Yeah, so it would be flipped, basically.
Yeah.
So the the x minus 2 to the 1/2 would be at the top, and the 2x plus 3 to the 1/2 would be on the bottom. That's what would happen. Time, and now you've got 2x minus 4 minus 2x minus 3 all over x minus 2 squared. So those cancel out. So now you have, let's see. So now you have -7 on the top, 2 and 2x plus 3 to the 1/2 power on the bottom. And then this, I'm going to combine those together, subtract them, right? And then on the bottom, I would have the 3/2. I would have x minus 2 to the 3/2 power. So it's the same thing. But But for some people, it would be harder to know what to do with this than it would have been to do that. Either either way, it's pretty tricky.
Yeah.
Either way, there's a lot of algebra manipulation that you have to do. Okay, but you'll notice that they're both give you the same answer if you do them right.
Okay, I have one last question. Sorry, it's number 33, I believe. Yeah, I can paste that in just one sec. This is the first part. And then I'll crop the graph right now.
Okay. Okay. Yep. So it's a half circle. Radius 5.
Yeah.
So the function value at 3 is going to be 4, right? Just basically plug it in, plug 3 in here. So that's 25 minus 9, which is 16. The square root of 16 is 4. Got it?
Okay.
And the derivative at 3, well, let's take the derivative. And I'm going to have to use the chain rule, right?
Mm-hmm. Which is
X squared to the negative 1/2 times negative 2x. So the derivative at 3, I'm not even going to clean this up yet. I'm just going to leave it in that messy form right there. There's no reason not to. So the 2 are going to cancel. So it's going to be negative. Sorry, I'll do it like this. 25 minus 9 to the negative 1/2 times negative 3. Right? So this is 16 to the negative 1/2 times negative 3. 16 to the negative 1/2 means that 16 to the 1/2 power is on the bottom, which of course is just 4. So negative 3/4 is your answer. And if you look at it up here, you can see that the slope of that tangent line should be negative, and 3/4 sounds about right. Negative 3/4.
okay. And I did want to clarify that like the chain rule is like what I think it is, which is like the derivative. Hold on. Let me word this better. Like if you have this and you have g of x with hx inside of g of x, you have the derivative is going to be like the derivative of g of x times.
Hold on. Careful how you're writing it. It's going to be the derivative of g with h of x unchanged. That's how you should write it.
Oh, okay. And then times
the derivative of h of x.
Yeah.
Yeah.
Okay. So it's still inside?
Yeah. You leave h of x inside of the derivative. Look at what we did back here. Oh no, right here. We did it right here. This was your h of x. Your h of x is 25 minus x squared.
That makes sense then. I was a little confused for a second. That makes sense.
Yeah.
Oh, okay. Thank you. Would you be up to one more question? Or
Yeah. Sure. Yep, it's fine.
Okay. Remember. Oh yeah, what? It was 19. Okay, it was. Yep, because that was product rule and quotient rule. All in one. I put it on slide 5.
Okay, so now we're going to use the, the quotient rule. So
Well, how would? Oh, sorry.
you don't really need the product rule for this one. Honestly, you can just take this 3 and this 2, and you can pull those out and kind of leave them just in the front of the whole thing if you want.
Leave what in front of the whole thing? I'm so sorry.
The 3 and the 2.
Oh.
Because the derivative of because the derivative of anything, when you have a number in front of it, that number just stays in front of it and gets multiplied by whatever is left over. If you have a factor in front of it, I can't think of what that's called. The coefficient's always going to be still sitting out there. You don't have to do it that way. You can go ahead and distribute if you want, or you can do, but you had mentioned the product rule. You don't really need the product rule here.
Oh, really?
No.
Oh,
So
yeah, because it's like a binomial, not like.
Yes. So it's low, D, high. So the derivative of that top thing, that 3 gets multiplied in here, but the derivative of 3 is just nothing. It's 0. But then it also gets multiplied in here. So the derivative of -3 sine x is -3 cosine x, or cosine. So it's low, D, high. The derivative of the high is just -3 cosine theta. You get that? Minus high, which is 3, 1 minus sine theta. That's the high. Times the derivative of the low, which is 2, -2 sine theta, all over low squared. So when I clean that up, that's going to equal -6 cosine squared theta.
To be honest, you asked me if like I kind of understand this part, and I am a little confused on it. Like, I don't know.
So here's your low, right? And what's the derivative of this here? What's the derivative of the high? If I told you, hey, tell me what the derivative of 3 times 1 minus sine theta is, what would you tell me the derivative was of that? How would you take the derivative of this?
I don't know. Isn't there a rule for like 1 minus sine where it equals like 0 or 1?
You're thinking of limits.
Okay.
As something goes to 0. Yeah. But good memory. But no, that has nothing to do with this. So if I distributed that 3 in, now can you tell what the derivative is going to be of that?
Oh, it's going to be like.
What's the derivative of 3?
0.
Good. And what's the derivative of -3 sine theta?
That would be -3 cosine theta.
All right.
Oh, okay.
Yeah. And that's what's right here.
Gotcha.
Okay.
Mm-hmm.
So cleaning that up, it's going to be, and I'll clean this up here too. This is going to be -3 plus 3 sine theta and times -2 sine theta. So when I distribute that, it's going to be plus 6 sine theta and then minus 6 sine squared theta. So I was just very careful on doing that. Okay. All over 4 cosine squared theta, because I just squared it. Now, what happens to this, this, and this? What's
you get 2 of them.
yeah, but do you notice what's -6 times sine squared theta plus cosine squared theta? What's this equal to? Doesn't that look familiar to you?
Yep, that's 1.
It's 1. Very good. So that just goes to 1. So this whole thing just equals 1, actually -6 plus 6 sine theta all over 4 cosine theta squared.
Okay.
So that's how that's simplified. Okay.
Okay. And since he likes it simplified, I can show you like.
Yeah. So maybe you'd want to take a 6. Yeah, because you can cancel out a 2. You can cancel out 2 from this and this and this. So this would be 3 and 3, and this would be 2. Yeah, and then you could factor out that negative. You could factor out the 3 or a -3 if you want. So he's factoring out a -3 so that he can write this as a +1 minus
Oh wait,
theta.
it's a positive sine theta. I think. Wait.
Yeah, there seems to be a mistake somewhere. I don't know if he made the mistake or if I did. You factor out a -3, so let's see. He says that it's 1 plus sine theta.
Yes, he did.
So I wonder if I made a mistake somewhere. It's easy. It's easy to make mistakes in here.
True. Very true.
-3 cosine theta. So it's 1, 3. All right, let's check it out. Low d high minus high derivative of the low is going to be -2 sine theta, right? So then I took the -3 and I distributed it in -3 times 1 is -3. -3 times negative sign is a +3. So then this times this is going to be a +6 sine theta. And this times this is going to be a -6 sine squared theta. I think I did it right. And then that becomes just -6 plus 6. -6 plus 6 sine theta. So if I factor out a negative, I think I did it right. I think his is wrong.
I could go over the work, and then if it's like that, then I could ask him tomorrow in class.
Yeah, I would ask him tomorrow in class.
Okay, I will.
I would say, you know what, I was doing this problem and it seemed to me like this should be a negative, not a positive.
All right, I'll ask him. Oh,
Yes.
and thanks so much for doing this with me. Even
Yeah,
though
no-
you're sick, I'm sorry.
Oh, no worries. Let me see if we might even be able to simplify that more, because the cosine squared theta equals 1 minus sine squared theta, right?
Yeah.
Which means it equals 1 plus sine theta.
Wait, I think
One
what he wants is like almost to combine like terms instead and kind of like subtract this from -6 sine squared so that you get.
Those aren't like terms, because this is sine and this is sine squared. It's like x and x. They're not like terms.
Oh, yeah, good point.
So actually, I think what you should do, to be honest with you, I believe that this would be 1 minus sine squared theta I think you can cancel this out. So this equals -3 times 1 minus sine theta all over 2 times 1 minus sine theta, because it's a difference of perfect squares. 1 plus sine theta. So these would cancel out, and you would get -3 all over 2 times 1 plus sine theta.
Oh wow, that's like even more simplified than his.
Yeah, and the only thing you'd have to do is you'd have to stipulate that 1 minus sine theta. You'd have to stipulate that sine theta could not equal 1, because then you would have 0. You'd have a 0 either in the top or the bottom. So that means that theta cannot equal.
Oh wait, wouldn't cosine squared equal 1 plus sine squared, not 1 minus sine squared and 1 plus sine squared? Because that would.
Isn't the formula sine squared plus cosine squared equal 1?
Yeah.
So wouldn't that mean that the cosine squared is 1 minus sine squared? That's what I did.
I mean, yeah, but then would it really be this then?
Well, look.
Oh, because you can multiply them.
It's a difference of perfect squares. What happens if I
Yeah.
a squared minus b squared? What does that factor into? A minus b, a plus b.
Yeah, my bad.
Right?
You're right.
So that's what I did. And so I think that's the answer. You just have to say that theta can't equal, let's see, sine as your y coordinate. So theta can't equal 90 degrees. It can't equal pi over 2 plus or minus 2 pi k. Theta cannot equal pi over 2 plus or minus 2 pi times k, the integer k, which I know is a little bit of a technicality, but that you really should say that, because when you cancel out a factor like this, this new thing, it makes it look like this new thing here. It makes it look like you could plug in whatever you want, but the one thing you're not allowed to plug in is something that would have made the original equation that we had indeterminate. So this thing can't equal 0, because 0 divided by 0, just you can't do that. So what am I not allowed to plug in? I'm not allowed to plug in, and you can see it here too. I'm not allowed to plug in anything that makes where the cosine is 0. And where's the cosine 0? The cosine is 0 at pi over 2 and anywhere 360 degrees from that.
Got it.
All right.
That makes sense then. Thank you.
No problem. Is that good? Feel like you got everything you need today?
Yes. I guess, to be honest, just my mom just